my YouTube viewers, it is Crystal here, and what I wanted to do is I wanted to make a video for you on how to determine a sample size in Python. So what we're doing is we're using Python to actually determine a sample size. So the first thing that we do is we use Jupyter Notebook because that's an online Jupyter Notebook, and we're going to use Google Colab for that. And first thing I want to do is I want to talk to you about the steps involved in actually determining your sample size, which is going to be number one, you determine the population size if known. 2, you determine your confidence interval. 3, you determine your confidence level. 4, you determine standard deviation, and 0.5 is safe when the figure is unknown. 5, you convert your confidence level to a z-score. And 6, you put your figures into a formula, and the sample size, it gives you a sample size formula that you can use. So the first thing I'm going to do is I'm going to give you how to determine the sample size from an array of data. You're going to import NumPy as NP, that's going to perform your numeric computations, and then you're going to import SciPy from SciPy import stats, that's going to be your scientific calculations. So we're going to have a small array which we're going to define as data. And then so the sample mean equals np.mean data. Sample std equals np.std data with a degree of freedom is 1. N equals length of data. Standard error equals sample std over np square root of n. And then you've got your confidence level is 95%. Your degree of freedom equals n minus 1. Your t-score or your t-critical equals stats.t.ppf. That's a percentage point function. Brackets 1 plus confidence level, brackets divided by 2, and then degrees of freedom. And then we calculate our margin of error. Your margin of error is your t-critical times your standard of error. Then you determine your confidence interval. And so your sample mean minus margin of error, comma, sample mean plus margin of error. And then we print all that up. So we print it all out. And you say your sample mean is 18. Sample standard deviation is 5.23. Sample standard error is 1.85. Your t-critical value is 2.36. Your margin of error is 4.37. And your confidence interval is 13, to 22. So it can be anywhere from 13 to 22. So now what we're going to do is we're going to talk about the confidence interval if you know the population proportion. So your p-hat is also like a probability. So your p-hat is 51%. Your n, that's the number of samples, is 210. So your standard error equals np dot square root p-hat times 1 minus p-hat over n. Your confidence level is 95%. So again, your z-critical equals stats.norm.ppf, and it's going to be brackets 1 plus confidence level divided by 2. And that's also your z-score. And one of the problems that you get when you're dealing with statistics is they call all these variables different names. So the z-critical is also a z-score, and it can also be a z-statistic. And so sometimes I'm a little bit unsure about what to use, because if I'm using somebody else's formula, if I'm using a formula made by somebody else, then they would call it z-critical or z-score, and then you've got z-statistic, and you never know what to use, but a z-critical is a z-score. And then we check our margin of error, is Z critical times standard error, and then we check our confidence interval equals p hat minus margin of error, comma, p hat plus margin of error, and then you print all that up. So our sample proportion, which is p hat, is 51%. Standard error is 3%. Z critical value is 1.95, which is also a Z-score. Margin of error is 6.7%, and confidence interval is 0.44 to 0.57. So now we're going to do some real-world examples on how to calculate the optimum sample size. So how many boxes of batteries to open to determine average number of defective batteries contained in a box. And so we're going to import math because Python has an inbuilt function called math. And then we're going to import scipy.stats and then import norm from scipy.stats. So your margin of error is 3%, confidence level is 95%, and your population standard deviation is 90.9. We're going to calculate the Z-score for the given confidence level. Z-score equals norm.ppf. That's percentage point function. 1 plus confidence level divided by 2. We're going to calculate the sample size. Sample size equals Z-score times population STD divided by margin error. And then we're going to square that, raise that to the power of 2. And then we're going to round up to the next whole number since the sample size must be an integer. So sample size equals math.ceil sample size. And then we're going to print it. So you're going to have a sample size of 35. So you're going to need to have 35 boxes of batteries to open to determine the average number of defective batteries. So that's your sample size. And so what math.ceil does is that rounds that up to the nearest value. And the reason why it rounds it up to the nearest value is because you can't have half of a box. You have to have a whole box. So on this particular one, we're going to have a pollster wants to have a margin of error of 3% with a confidence level of 95%. So again, we're going to, from scipy.stats, we're going to import norm. That's your normal distribution. And we're going to import math, which is an inbuilt module in Python. So your margin of error is 3%. Your confidence level is 95%. Your p hat, or your probability, is 5. So that's estimated population proportion. Z-score is norm.ppf, brackets 1 plus confidence level divided by 2. And your sample size is Z-score raised to the power of 2. So that's squared times p hat times 1 minus p hat divided by margin of error squared. And then we're going to round that up to the nearest number. Sample size equals math.ceil sample size. And so the sample size is 1068. So that's how many people you would need to poll. How many people you would need to poll to have a margin of error of 3% with a confidence level of 95%. So those, I've given you two real-world examples on how to calculate sample sizes. One of the ways to calculate sample sizes is with the margin of error, the confidence level, and the population standard deviation. And the second way to calculate the sample size is margin of error, confidence level, and your p hat. So that's it for this particular video. We've given you information on how to calculate the sample size in Python. So thank you so much for watching my video. If you like my video, please like and subscribe. And I look forward to making more videos of a technical nature for you in the very near future.